What is natural language processing?
If I can explain in very simple terms, making computers understand what we write or speak, or making computer write or speak.
Why do we need NLP? Let us take a live example. Suppose if we search TikTok VIT Devghar, we are directly directed towards the official web page. And obviously we don't want to search millions or trillions of web pages. How computer understand our language? Or how computer understand translations, English, Hindi, and other languages. What makes NLP hard? First, text and their pronunciation. What computer will pronounce? Read or read? Second, word and their meaning. For example, word bank, or let's say I am standing near bank. Which bank? River bank or financial bank? Or the word apple. What do you think? What it will show? Either Apple logo or original Apple. Here the computer confuses. Apple, apple. And the third one is intention of sentence. For example, it's hot out here. Where? This type of sentence creates confusion in computers. NLP is hard, but it is not very hard. Let's move on. How to deal with text data. NLTK stands for Natural Language Toolkit, which is a very powerful Python package that provides a set of diverse natural language algorithms. It basically helps the computer to analyze, pre-process, and understand the written text. What kind of written text? Let's see with an example. Now, text analytics have a lots of applications in today's online world. For example, we know Twitter. Now, by analyzing tweets on Twitter, we can find trending news and people's reaction on a particular event. Similarly, Amazon, in which they can understand users' feedback or reviews on a specific product. And a very good example coming on my mind is Book My Show, in which they can discover people's opinion about a particular movie. And again, YouTube, on which they can analyze and understand people's viewpoint on a particular video. So these are one of the major examples in which text analytics is being used. So how our model looks like? Let's see Amazon review system. There is an input X. Then we have a model, a classification model, which can tell us whether a review is positive or negative. So here X is an input, which is a text. But we all know that a computer system cannot understand a normal English language. So there is a need to convert our text to a vector so that we can use linear algebra. Now the question arises how to convert. Text should be converted to d-dimensional vector. So a very simple rule is that similar text must be closer geometrically. Now there are several techniques for doing this like bag of words, TF, IDF and so on. How to perform text analytics operation, which involves the basic text pre-processing steps like tokenization, removing stop words and normalization. Let's see how to apply them. So first obviously we import NLTK library and will download a sentence tokenizer here, that is T. Now what is tokenization exactly is? It means that to break down a text paragraph into smaller chunks such as word or sentences. Because any paragraph is composed of words or sentences. So token here is the single entity that is building blocks of sentences or paragraphs. Now here let's start with sentence tokenization, in which we need to break the text paragraph into sentences. Here I have an example with 4 sentences. That is this one. From nltk.tokenize library, we import sent_tokenize function. This is a variable which is equal to sent_tokenize, and in this function I am giving my text. So have a list of 2 elements. Similarly, word tokenization, which breaks the complete paragraph into individual words. We will import word tokenize here. Let's see, we can see that each word is getting tokenized. You can see the frequency distribution, that is which word is coming how many times. I use the function freqdist. I have the variable fdist in which we will use frequency distribution function, and in this I sent my tokenized word list as an input. Got 23 words and 37 total words. Here we got 2 most common words. Word number of times. This is frequency plot of all the words. Now next step is stop words. This is very important step in pre-processing. Whenever we have text corpus, there are noises in that text. In English we have stop words, which are like the words that are not useful to get the semantic output of any comment, any review or any text. We will first download the package of stop words. Now from nltk.corpus, this package will import stop words, which is an inbuilt function through which we will able to access stop words that are already there in package. I am using set function. How we can remove? Initializing an empty list. If W is not in stop word, return the word. Earlier tokenized sentence, filter sentence. These stop words are one of the noises that are in corpus. There are other kind of noises as well. To remove, we can take out the data through this lexical normalization, which is used to remove derivatively related forms of a word. Like a word connect, we have connects, connected, connecting. All these are words that have a common root word connect. We want to reduce to their root word from nltk.stem, import porter stemmer. Now this is one of the algorithms. Stemming involves few algorithms like porter stemmer, and we have another snowball stemmer also. Variable ps, empty list here. Run a loop here, return the filter sentence, stem sentence. Here stemming includes upper to lowercase conversion, says change to say, but some of the conversions are really meaningless, like hated here. HATR does not make any sense. So here comes the picture of lemmatization. This is similar to stemming, but this converts the word which is linguistically correct. Lemmatized word. Stripes. I want verb, so it will give me the word strip. Instead of a verb, I want noun, so it will give me the noun stripe.